Hi everyone, so today I'm going to show you how to make time series of a precipitation data from MRMS dataset. So these datasets are called multi-radar, multi-sensor precipitation product. So we'll read in the last tutorial we saw how to read a NetCDF file, because these are the NetCDF file we have. Hourly time step is file contains precipitation, right, in terms of latitude and longitude. So now I'll show you how to extract a time series, how to make time series out of these files, out of this hourly series. We'll make the hourly time series of our precipitation data set. So how can we do that in Python? Let me just show you pretty quickly. So I just modified everything. So what we need to know for reading any data set, right, that is in NetCDF format, we need to import NetCDF module, and from NetCDF module we are just importing that method dataset, and we need to do some operation in NumPy array. So we are importing NumPy array, pandas as before, and time delta, because we'll deal with time. And if I want to plot, so that's why I'm just even importing matplotlib as pyplot, right? And if there is any warning, I'm just suppressing this warning. Okay, and what I'm gonna do here, I'm specifying my input directories where I have all these NetCDF files. So here I have all these NetCDF files. I can't open using my right click and any editor. It is not possible. We need a spatial coding, that NetCDF module. So we already have idea about, right, how to open or read any variables from a NetCDF file. You can use the same command for any NetCDF file, and you can see the variables, you can see the dimension, you can see the units, everything there. So I'm just here, that's why I'm just commenting my specific directory that I showed, right? So I have everything, all files in my input directory. How many files I have? Let me just quickly show that. I have 289 files. I have this time step and 289. These are the hourly, okay? And then I'm specifying the output directory as I do usually, and it is even I can specify there. That is my output. So other than doing that, I can specify in my download directory. Okay, this one I'm specifying this, and I can even specify, okay, time series. Okay, MRMS TS. Now what it will do, it will check if this directory is there already, then it won't create anything. If it is not there, then it will create. So that is the command I always use. If not os.path.exist, then it will create. Okay, and then I'm just printing some message that okay, it is reading the observation stations. Now what we have to do, let me just show you that I have this CSV file, list of latitude and longitude. Okay, so list of latitude and longitude. So here it is here. So I'm gonna extract data for these stations. I have like 31 stations. So that is basically the name of the stations, and these are the longitude and latitude. Okay, longitude and latitude. That's why we converted, because the latitude and longitude should be in -180 to +180. But our data was in 0 to 360 degree. So we converted it to -180 to +180 degree. So I have the longitude and latitude. If I want to make time series for this location, I'll use that longitude and latitude, and I'll just go through all these files, NetCDF files. I'll loop through all these files. At first, I'll loop through this CSV file to read first location, and then I'll start looping through all this NetCDF file, and I'll make time series for this one. Then I'll go to the next point and I'll loop through all of these files, and then I'll create the time series for each of these stations, and it will create one time series along. So the first column will be dead time, and the second column will be the precipitation, hourly precipitation or rainfall data. Okay, so let me just show you. I modified the code and I have that code here. So I'm specifying the directory where I have that CSV file. Okay, so that is the command to read any CSV file. You may have idea about that one, or I can quickly show you that what it is actually giving. So if I want to import that pandas pretty quickly, here I'm just showing you import pandas and what actually it is giving. Okay, so I'm reading the stations this way. Okay, station, and if I just run, so I have the station name here. You can see I have the same format. It is giving me the field ID, first one, and the station, and then the longitude and the latitude. And if I now loop through that stations, okay, so how can I do that? So I use the key. Key means the index and the value, right? Key and comma value in what? Stations. Stations dot, because it is a data frame now, right? And then we have to use that command iter rows, because we want to iterate over rows. Okay, iter rows, and it will be this one, stations dot iter rows. If it is okay, let me just check. Value for key dot value iter rows. Yeah, definitely. Okay, so now I'm just printing. Okay, print. I'm printing. If you print key, it will give you the index. Index means it will give you the first index 1 to 3. Okay, so let me just print what it is giving. See, it is giving me the indices of these files, but I don't need that. I need the value. If I just use a value, and the first, I have to use even the column index. If I want to extract the station name, I have to use 0. Okay, 0 means the field ID, 1 means the station ID. Okay, and it will give me the station ID, not this one. It is giving me the longitude, should be 0. That's why you have to check. See here, it is giving me the station ID. And even you can print value, you can access. This is how we can access. 1 means longitude, and it will plot longitude and latitude at the same time. So this is how. So it will plot the station name, then it will give you the longitude and latitude, right? So this is how we can see it is giving me this way. The first I read the NetCDF that CSV file, so it is now a data frame, and then I'm just looping through that data frame using this command iter rows, and then I'm just accessing the values, each of these values. So when it is looping through these values for first one, for example for this one, so when it is value and the 0, I have the station name, and then when it is value 1, it is the longitude for that one, and if it is value and 2, then it will give you the latitude. So this is how we'll access to this latitude and longitude, and we'll use that values, right? So that is the logic I used here. At first I'm looping through my input stations, right? So this is how I'm printing that station name, value 1 and value 2 means the longitude and latitude, and then I'm creating the station name, right? I'm creating the station name, adding high watermark. This is called HWM. We can exclude that one, it is not a problem. So how I'm on, how to just write that NetCDF file of the time series, what will be the name of the time series. So I'm preparing that station name. Okay, I'm preparing that station name this way. So you'll see that will be my station name. I don't want to print that, so that will be my station name. Okay, station name. So I'll save the CSV file by this name so that we can understand. Okay, so that will be the name of the CSV file. See, so I prepared this name. If you just follow, if you just already have idea about how to save NetCDF file or how to save any CSV file, so you know that you need to pass any name. So I'm just creating a general name, right? Even I can exclude that. Yeah, for this time, for the time being, I can exclude the first part, value. Okay, I don't need that, so I even don't need that one. I can use value, I can use value 1, then it will give me only this part. Okay, so this way, see, oh no, that value 0 should be value 0. So it is giving me that So that is okay. We'll use this station name other than that one. Let me change that code now. Okay, I'm not gonna use this. So for station name it is this, and yeah, for the time being I'm putting that way. So station name will be that. Okay, so that's that. Now I have the station name and the name of the CSV file, and now I'm just see lat point. So if I use value 1, it will give me the longitude long, and the latitude it will be value 2, the index 2. It will give you that one. So now I have the latitude and longitude for each of these stations because I'm looking through that file. So the first station, okay, for the first station, for this station, I have the station name. I prepared the name of the CSV file, and I have the point. Now we will use this point to extract or find our precipitation value. So that's why I'm creating here date time empty list, because I don't have the information inside that file. This date time should be extracted from the name of the file, because I know the date time, right? It is mentioned there. It is mentioned there, right? See, that is the date time 2018-09-08, September 8, and the time is 00 hour, and then we have 1 hour, 2 hour. So this is how we'll extract the date time from the file. We'll split the file name and we'll extract the date time. We'll make the date time list, and this is how we are assigning an empty list, and the variable, it is also an empty list. So here in the date time list, we'll make a list of date time for that corresponding date time for each of these files when you look through each of these files, and then we'll add the variable, means the precipitation value or whatever the variable you wanna extract. Now the same, I assign the input directory. Now I'm changing my directory to the input directory where I have all these files. And as before, if you already watched my previous tutorials, then you can see that, okay, we need to change the directory where I have all these files, and now I'll make the list of these directories, right? List of files. So that is the command I'm using for loop. So time step, and because each of these files are for time step, I'm assigning this way. This is the key or index. So time step and the file name in enumerate, I'm enumerating. If you use this command enumerate, then you can have access to the file name and index at the same time. Okay, so the first is the time step. You can use 0, means the 0 time step, 1 means 1 hour. So that's why I use enumerate command, or you can even use now for file name in os.list dir as before I used. Okay, we can follow the same thing. And now I'm using, see, in a previous tutorial what I did, I even use file name dot ends with CSV, but now I know the extension .NetCDF, so I'm just looping through only the NetCDF files, even though I know, okay, all these files are in NetCDF format. So still I use the same common format, so that, yeah, it is standard practice. And now I'm splitting as before. Previously I splitted CSV file, but now I'm splitting this NetCDF file. When I split this NetCDF file, see, then I just pasted one name, so it will form this part as file name, and the extension will be .NetCDF file. So once I have that extension out of this file name, then I have to grab this part. This is the date, right? This part is the date, and this part is the time. So that's why I'm splitting again. See, date type, date, and grep using that dot, because I have dot here. If I use dot to split again, then it will be splitted by this part. It will be one part is there, another part will be there, and another part will be there. So I don't need this grep 2 or first part. I only need that part, right? So that's why I have to split it again. I have to split it again using that underscore. So here is the underscore. If I use that underscore, so this will be another part, this will be another part, right? This will be another part. So that's why I'm using null and date. So after that underscore, that is the date part, dt. So I'm concerned on that. And again, I'm splitting this part using that hyphen. So now I will have this hour, month and day, right? Year, so that is the year, month and day, and that is the hour. So I'm just splitting using that hyphen. So now I have access to this one, this part and this part separately, and then I'm just, what I'm doing here, so out of this 6 digit, I need to know only this 2 digit, right? These are the hour. So that's why I'm using only this index 0 to 2, means that is the 0 index of 1 and 2. If I use this 0 to 2 limit of this indexing, so it will give you only the first 2 digit. Okay, and then what I'm doing, I'm just adding these two because these are in string text format. So I'm adding, then it will give you that 2016, right? 2016 08 01 and 00. So that will give you this way. So now I'm just printing this one, that one, but see the same command I used in the previous tutorial. I'm reading the data and passing the file name, because I'm looping through each of these files now, and then I'm reading it in reading mode, and then I'm using the same command. I'm extracting the unit. If you use this data.variable and if you pass the variable name and dot units, it will give you the unit of that variable name. Since I need to know the variable unit, so I'm assigning 1 unit. Okay, and then I'm extracting the precipitation, all this precipitation as array. So data.variables and name of the variables I already showed you, right? How to even display the name of the variables, and I'm using this colon, means all these values that will be inside my precipitation. And what I'm doing here, if there is any missing value, then I'm just using that field value command. If there is any missing, so it will replace by 0. Definitely there is some, I checked it, there are some null value. I'm replacing it to make the data frame consistent. Okay, and there are some also negative values because of that sensor data. If it is less than 0, so I'm assigning that value as 0 as well. I'm just treating all these values, and then I'm printing. It will show you after treating, show you that. And I'm even assigning, extracting all this longitude, all this latitude. Since the longitude are in 0 to 360 format, I'm converting this to -180 to 180 here. And that is the trick here. I'm just creating a square difference of the latitude. The latitude I'm passing, and I have the latitude like 3500 by 7000, right? So it will do the operation for 3500 by 7000. How many points we have? If you multiply, you will have that number of point. So it will just deduce. It will take the square difference for all these points, and it will put inside that square difference latitude array. And then I'm doing the same thing for longitude. So I have this. So now I'm taking the difference between latitude of my point and all of the point, right, that is there on the data set. And for longitude, I'm doing the same. Now if my point is close to any point within that array or within that NetCDF file that is assigning their latitude and longitude, so I need to find that index. So what is the command for latitude and longitude? Because in order to extract the data, I have to pass the latitude and longitude. That's why I'm using that index, right? So that is the square difference array. So I'm using that .argmin. So that will give me the minimum square difference between my point and all this 3500 and 7000 points. So it will find the index of the minimum of value, right? So that means the point that is closest to my point, it will give me the index, and for the longitude it will give the same value. Once I know the index, then I can query, okay, this is my index, give me the precipitation, right? So that is the point. And here, since I have the empty listing date time here, I assigned there at the beginning. So now I already have my date time, so I'm just appending. That is the general command. I'm appending to my empty list. So date time is my empty list, and I'm append command. It will append the value inside that parenthesis, and I'm converting that year, month, date, and hour. And right, I'm using date time. I'm converting it to date time format, and that is the command date time dot strap time, and I'm passing the format. It will give this format: year, month, day, and hour. That is the standard command for creating date time object, right? And then I'm writing that variable. So for each of this file, I have the empty list. I'm looping through each of these files, and I'm reading the date time and appending there. And now I'm appending the variable. So variable is the empty list, and then append and precipitation. So in this precipitation or what I have entered array, right? So now I'm passing minimum index of the latitude and minimum index of the longitude, because this is how we can extract that point. So it will give you the precipitation value close to our point. So I'm appending there. And here, since I'm using if-else command, if the file ends with NetCDF, then it will do this operation. Otherwise, it will show, okay, there is no NetCDF file in the directory. So this is a standard way to write a code. So I'm doing this. So once it will loop through all of these files, see, it will loop through all of these files, and it will make a list of date time object, right? And at the same time, the variables we need, the precipitation for this case. And then I'm creating an empty data frame with date time. So that is the date time. I have the date time list, and I'm creating a data frame, new data frame. So that is the command pd.dataframe. It will create data frame, and I'm passing a list of date time, and I'm assigning, okay, the column name will be date-time, okay? And then I'm setting that column as index. Okay, so I'm assigning, okay, that date time is my index, and then I'm passing my variables here. I'm adding that. I have a date time column, and I'm adding next to that column my list of precipitation. So then I'm assigning the name of the column as millimeter per day. But for this case, it will be, if you don't multiply, because these are the hourly data, if you want to calculate that, you need to multiply by this one. Since we are not multiplying, it will be millimeter per hour for this case, and it will give you the data set, what it is actually doing, and then it is saving. See, now it is the standard command. It is saving this data frame df into CSV file, and I'm assigning where to save, right? It's the joining the output directory, as I mentioned in my previous tutorial, and I'm passing the station name. That's why I created the station name. And index equal to true means the date time index we created, it will give you that date time as index. Otherwise, it will create another 1, 2, 3 a column, number of column, okay? And then it's done. Now I'm just plotting. It is the standard format of plotting. Since I have a 2 column, first column is date time and second column is precipitation. I'm just assigning, okay, that is my figure size, that is my title, and everything is that. Okay, plot it. So for plotting, I already discussed about that one. So this is how I want to create. So it will do the job for one station, because the main loop I'm doing here, it is looping through my list of stations. So it will do the thing for each of this station. It will loop through first this station, and it will use this lat long, and it will loop all these 289 files, and it will do all these calculations. It will grab each of this data for each of this time step, and it will make empty list, and it will fill that empty list, and then it will plot finally. Okay, so let me just run the code here. If I just run the code, it will start doing that. Okay, yeah, see, on the right side here you can see the message. It is showing the rainfall data for time and step. This, see, it is changing time. See, 1, 12, 15, 16. Once it will be 23/4, so it's changed the date. Okay, it already got changed. So this is how it is reading, and it is showing the data. So that's why when I write any code, I just display the messages, right? For each of this time step, or for each of this step, it just loops through any data set or what it is actually doing. Otherwise, you won't be able to understand. So see, it created, maybe let me check in my data directory. There won't be anything. See, I have only AMR, MSTS, but inside that there is nothing. Is there anything? No. Once it's done, it will create the name, first name, CRMS 0061, and it will give us a what? Time series. So let's wait for that one, and let's see what it is actually doing. It is pretty fast. See, it is doing this job here. I think it won't take too much time because it is for 9 days only. I'm assigning here. It is for 9 days. And now it is up to 12. It's pretty fast. So yeah, so that is the logic. Once you have more than 1 point or 2 points, so create a CSV file, list of the file, and use your latitude and longitude to extract data from any NetCDF file. So for doing that, you have to just think about the algorithm, right? How can you do that at once? You can easily do that. So that is the entire thing. I'm looping through my input station name with latitude and longitude, and I'm using that information, and then I'm looping through each of these files, means the NetCDF files, right, from which I have to extract data. Since these files are in hourly time step, I'm looping through each of these files, and from the name of the file I'm extracting the date time information, and I'm creating the date time object, and I'm just listing this date time object, and I'm also extracting the precipitation by taking the square difference in between the latitude for my point and all this latitude and longitude that is already that are already there, right, from the data. Then I'm just calculating the minimum difference, since it may be positive or negative. So what I'm doing, I'm taking the square difference. You can take absolute difference as well. Then I'm using another built-in function, argmin. If you use argmin, it will give you the index of the minimum value of that array, numpy array, or whatever it is. And if you use argmax, it will give you the index of that maximum value. So that's why it is that command. So I'm just using that argmin, argmax to get the index. Once I have the index of the latitude and index of the longitude, because we already know that the first value should be index of the latitude and the second should be index of the longitude. So that's why we are passing the minimum index of the latitude and index of the longitude. So it is giving me the value of the precipitation that is close to my point, because we don't have anything to do. Otherwise, yeah, we can even interpolate. Yeah, I have another script that can interpolate, two-dimensional interpolation, because this data set, or maybe our point is not located on that node. So if it is close to that point, that means it is giving us the most accurate data. So this is how we can extract, and I'm just repeating for other points, and it is doing the job. Now we are right. I think it is done up to 16th of September. It will be, I think, up to 18th of September. We have 2 days, 17. So within 1 minute, it will be done. See, there is nothing here. There is nothing. It will plot, and we'll see, and then I'll stop my recording, and it will do the job if you just keep running. So that is the reason, if you wanna extract and read precipitation, you can do this way, because that is the hardest part. And there is another format, stage 3 precipitation product, that is even in different format. So I'll create another tutorial on that one as well. So people are sometimes they're looking for information that how to read that one. So I was also doing the same, and finally I figured it out, right? So it's almost done. I think it will plot. Maybe, see, it is 18. So when it is done up to 18, most probably, it is done up to 18 or 19. I can't remember, but it is gonna finish pretty quickly, and you'll see one plot there. You'll see one plot, and we can see the file saved as NetCDF at the CSV file, right, by that name CRMS and the number I mentioned there. So it's almost done. So you can try by yourself, and if you have any query or if you have any question, you can even search for help. So you'll see even similar command, or how to read NetCDF file. So that is pretty common. You have to install that NetCDF module using pip NetCDF, right? Pip install NetCDF. It is not that hard. And once you have this, see, this PC is slow. If I use this in my Linux machine, it would faster than this one. See, NetCDF files in the input directory stopped the program, and exception occurred. What happened? See, there is no NetCDF file. means maybe I already have, there is nothing. Okay, so it is looping through all these files and it is mentioning there is no NetCDF file. What happened? See, it is up to, oh, not this one. Where is that? Why it's showing there is no NetCDF file? So these are the errors you may have. So that's why you have to test the code output directory, stop the program. Why? What happened there? Is there any line number? No, it is showing this message, right? There is no NetCDF file because there are NetCDF files. It is reading all of them. Yeah, we have the NetCDF file here. I specified the directory mrms NetCDF file. Everything is there. Okay, so let me just check. Sometimes this happens. It is not a problem. So if I run this code in my Linux machine, I have done this. Sometimes this happens and you have to figure it out. See, it done, right? It's done up to 19 and 23. Let me check the value if it is there. Of course it should work. There is yeah, that's why I like that. If I have some error, I can read. Oh, it's done. And I have the pressif. Oh, I don't need that one. Okay, maybe because of I specified that one. See, so it previously what I had, I tested this one and it created this way. It created the time series. This time series basically it will create this time series. It is where is the name of the file? It is specifying the station name. Yeah, millimeter per hour. This is millimeter. Yeah. So it will be like this. The precipitation time series will be like after 1923. It is the same I tested previously and it saved there. But why it didn't run? It is showing exception occurred. Use tab to see all this. Okay, I don't need to see because I know what happened. There is nothing wrong. I can't see anything. Everything looks okay. And if I just clear all these variables, yeah, all these variables and removing all these things, and let's check. Okay, let me just run it again. If it works, then yeah, I'm coming back again, not a problem. Okay, so until then, yeah, I'm just checking. I'm checking out of this video. I'm just stopping here and then I'll come back again. Okay, just I tried what happened. I just looked at it. So it is nothing but I had because I had one extra CSV file, so it was looping through each of these files, and that's why it created that problem. So what I did, I just removed that file. Otherwise, see, it was showing if there is no file, I have other file other than .netcdf4, so it was showing that error. There is no NetCDF file, and it was not even jumping to the next step. So that was the problem. So I removed that CSV file from that directory. Otherwise, I should remove this else condition, right? So because it has within the list, the file was within the list, but since it is not NetCDF, so it was just exiting. So that's why I just specified that one. So we are just close to the time series. Let's see if it works. Definitely it should work because I tested previously. That's why I don't use this Windows most of the time. I use Linux. So whenever because in Linux sometimes you have the option to replace every time, but in Windows, if you open any file and if you create one, sometimes it won't replace. You have to, for example, for NetCDF file, it's pretty difficult if you open this file in a Jupyter Notebook. So if you want to remove that and replace with another one, it's pretty difficult. So that's why I use Linux machine most of the time. Let's see, it is pretty close to the end. I have 19 19th of September and 19 hour, it will be up to 23 hour, and then it should work. Yeah, it's plotted. See, it plotted the data and it started the next time step. So that was the problem. So if you have problem, you can understand the solution as well. So where is the file? I think it is there in our download, right? MRMS here. See, it created the file. See, here it is. The time series is this. It is the time, and that is the precipitation. If I just plot, it will be, yeah, I'm just quickly plotting using, that's why I use my MATLAB code to plot. So yeah, so that is the precipitation. See, it is hourly precipitation. So I'll show how to convert hourly precipitation to daily and even monthly precipitation. Okay, so yeah, that's that. This is how we can extract, and you can make time series because it will take time. It is basically looping through the entire USA. You already have, right? It is the data set covers, right, the entire USA. And for example, I have one point there, this close to North Carolina there, and it is just finding that point, and it is calculating that index, minimum index close to my point, and then it is making the time series for that from that 289 files, and it is giving me the time series as CSV file. It is a huge calculation, but still it is pretty fast, right? So faster than human being as well. So it is, yeah, it will take, I think, half an hour or some, based on your number of stations you need to extract, but it's okay. We can keep the computer, okay, you can run it and you can give me the result as well. So that's that. So this is how we can read any problem and we can solve, and you can try by yourself. And yeah, in separate tutorial I'll show how to download all this data. So for downloading all this data, you need to even prepare some input file, and you can write a specific command and you can download that. So I'll make another tutorial or another series of tutorials that how to download different types of data set, because that is the most important right thing we need to know. When you have the data, then you can process, otherwise you won't be able to do anything. So thank you very much. I'm just gonna finish here. So thank you very much and stay safe.